Hello, welcome. My name is Noyes, and I'm one of the science teachers here at Noyes Classical School. So what is a classically based science curriculum? I'm glad you asked. It is our opinion that the scientific method, while it teaches us how to do science, does not teach us how to think about science. For generations, natural science was considered a type of philosophy and was approached as such. Those who study its evolution historically over time will certainly discover its humanity. While the modern digital reality of Google searches teaches and conditions students that information can be easily accessed, it fails to impart interpretation, value, or even context to that information. Knowledge is not the primary goal of education. Rather, it is to equip students to succeed at the activity of learning, which itself depends upon the practiced ability to think, organize, and communicate information. Now, we're all familiar with the scientific method, the 5 steps: observation, question, hypothesis, experiment, conclusion, and the transitions that occur in that flow, that progression. But what occurs before or after? Before the observation or after the conclusion, that is something that modern science curriculums usually fail to address. And I would pose to you that our approach in 3 parts attempts to supplement that and answer that question. So what defines our science curriculum here at Noyes Classical School? 1, the use of the imagination. There's this fictitious belief or assumption in modern academics that imagination is reserved only for certain subjects, primarily in humanities, perhaps like literature, poetry, art. However, I would propose, and we uphold, the value of imagination across subjects, across academics, and specifically in science. Without imagination, science is a dull and directionless activity. That imagination is not just a factor, but it is the key factor in the scientific education, allowing students to connect knowns to unknowns, allowing them to wonder, have questions unanswered. This allows them to build visuals. This is why we use charts and diagrams and pictures to represent information, and we do that using the process of imagination. 2, we attempt to avoid the building of units for students. So for example, if this diagram represents a normal science curriculum from middle school to high school, where you progress in sequence from unit to unit to unit, not going on to the next unit until all of the desired topics and subjects within that unit are adequately covered and tested, you get this linear progression of knowledge, which is a success. However, there's no connection. By establishing units, it imposes false limits and boundaries on the intellectual capacity, specifically for sciences, of the student. Rather, I propose that a science curriculum ought to look more like this. Here we have ununiform, sizes, locations, but each topic, again, represented with these circles, begins with a question. And as you learn more about that question, seek to answer it, you encounter more questions, more unknowns. And you might overlap with other ideas and concepts within science, right? Perhaps chemistry has something to say about biology. Perhaps physics and math can comment on each other and aid each other in this investigation of our natural world and universe. So as we seek to build units, we want a student to have a context for that information and to be able to apply that information, that it is a cohesive idea, that science is not unitized in real life, so neither should it be in the classroom. And finally, to be incorrect is to be a good scientist, oddly enough. That failure is an option. Now, we don't want our students to fail often, but when they fail, we want them to fail well. We want to give them the courage in the classroom to propose solutions, think of hypotheses, offer answers to questions, even if they had not encountered them before. For I'm not a scientist, I teach science. There's a distinction between me and a scientist. But I have friends and colleagues who are scientists, and they assure me that science is over 90% failure. And if we condition students to memorize, to recite, and we don't teach them how to analyze or synthesize within the sciences, we're doing them a disservice. So here at Seven Oaks Classical School, we seek to impart imagination. We seek to impart an idea that the sciences can be used to benefit each other, that they're ever expanding, and finally, that failure is an option. Now, if you have additional questions about the curriculum, use of textbooks or resources, and college preparation, I'd be happy to answer those as well. But thank you for visiting our page. Welcome to our school, and we hope that you enjoy it. Thank you. Goodbye.